Okay, so midpoint and trapezoidal, I think left and right are a little bit more straightforward. Midpoint trapezoidal, there's a little bit more math to it, and it becomes a little bit more complicated. And when we're looking at the accuracy of the approximation, we're not looking at increasing, decreasing, we're actually looking at the concavity. So there's something just a little bit different about it. So what we're going to look at first, again, is the midpoint and trapezoidal, and how you find each one if you were to have to draw it. So again, these are the exact same curves as on the previous page. So I'm just going to trace them both right now in pink, so that we can continue moving through this and actually get to the nitty-gritty. Okay? And we're going from A to B for both of these. I'm going to do one at a time, but I'm just highlighting because it's easier. Okay, so in the midpoint, you still have your interval from A to B, but in this case, I need the midpoint. So remember on the left, we would start on the left, and whatever our width was, then we would go to the next value and draw our vertical, our height up, and then go to the next one based on that interval. So the way this works, and again, as I was stating before, some of these methods are going to be more accurate, so it just depends. So if you know the true area and you're comparing, a question might be, which method is the most accurate? So which one is closest to the true area? And in your calculators, totally spit, sorry. In your calculators, I am going to show you actually how to find the true area. Okay, so when we get to it, which is on the bottom of this page. All right, so what you would do is, if you know the width, and let's just stick with 1 because 1 is nice and easy. If I said that we were going from 1 to whatever, and my width was 1, if I'm starting here at 1, I know that I'm going to have this endpoint here. It's going to stop at that portion of the curve, and I know that this value would be, using my example, 2. I could then draw another vertical here, but the issue that I'm really looking for is, what's my midpoint? So between 1 and 2, my midpoint is 1.5. So really, this is what I'm looking for. I'm looking to draw this vertical up here and create this point, and then I have to go out in either direction. So again, remember I said these are not my most favorite because they're not as straightforward. They're not as easy. Okay, so then you would have to create this rectangle going in either direction. So here I have this vertical, which was, this is my width. If this is 2 and this is 3, this is 2.5. I would have to draw this up and create that point on the graph and then go over in each direction to create that rectangle. So this is a little bit more time consuming if you were doing this without the template already here. Everybody with me? So then if this is 3 right here, that would be 4, this is 3.5, this is what goes up to the curve, and then you would go over like this, and so on. Does everybody understand? So then we would be able to find these the area of each rectangle, and then add them all up, and find the approximate area. Is this as easy as left and right? No. Okay, so the notation is the same. This is still 1, 2, 3, 4, 5, 6. It's M sub 6 to indicate the midpoint is approximately, and then you would calculate the area. And again, I'm going to show you how to do this. The trapezoidal is actually probably the easiest because you don't have to draw rectangles. You're actually drawing the trapezoids. So what you would do is, given your interval from A to B, you would draw your vertical up from your beginning. Whatever this width is, again, let's stick with 1 because it's easy, then this would be 2. And then I would draw my vertical all the way up to the curve, and then I just connect these 2 dots. Okay, so this right here is my trapezoid. You might not see it this way, but what if I turned it this way? Here's your trapezoid. So this is base 1, this is base 2, and this is my change in x, or basically my height. Okay, and then you would continue. So trapezoid is actually a little bit easier, but it's not as easy visually sometimes, because some of these things run together. So see, this just looks like almost a straight line here. So it's kind of hard to see with the curve. Okay, and again, this would be, excuse me, T sub 6 is approximately. So when we are looking at the accuracy of the approximations of these, all right, we've got the approximations of the midpoint and the trapezoid are looking at the concavity of the function. Okay, so trapezoidal is a little bit easier to see, and midpoint is exact opposite, so I'm just making this up, but if the concave up portion of a trapezoidal is an under approximation, then the midpoint is going to be an over. So we're going to do the trapezoid first, and then we'll just, because it's a little bit harder to see here. Okay, so we're going to take a look at the trapezoidal. So we're looking at concavity, concave up versus concave down. So if I look where my function on the trapezoidal is concave up, this is very slightly concave up. Can you guys tell me, is this an over or under approximation? Definitely over. So below on concave up, I'm writing over. It's right here. So for midpoint, that means that when the function is concave up, in a midpoint, it will be an under approximation. So let's look where the trapezoidal is concave down. You can clearly see it here. Is this over or under? It's under. So that means for the midpoint, this is going to be over. Okay? So again, if you were asked, okay, from A to B on the trapezoidal or even the midpoint, is that area an over or under approximation? If you said it's over and it says justify your answer, because the function is concave up on the interval from A to B, whatever it is. Okay? And it's really helpful if they give you the graph, because sometimes we don't know. Like this, I would have no idea what this function is, or what that graph would be. If it's, I don't know, negative x squared, then we kind of have an idea of what our graph looks like, and we can figure that out. Is everybody with me? Okay. So let's take a look at how do we actually, like, you're talking about all these things. How do you calculate it? Like, what are we doing? What's the math behind it? And when I do my homework, how am I going to do this? Am I just going to be analyzing? No. All right, so there's a lot of stuff here. One thing that I do want to talk about that we'll talk about more in detail, but if you're given a problem, you need to know what this means. It says, in example 1, Riemann sum is given a function in equal subintervals. So I'm going to talk about this in just a minute because it's really important. And it says, divide the specified interval into n is equal to 4 subintervals. Okay, and what that means is this is a number of rectangles that you're going to use to approximate the area under the curve, okay, of equal length. Then compute, and this is what I want to talk about right here, the integral from 0 to pi of the function, which is equivalent to finding the sum from 1 to 4 of basically the areas of the rectangle, which is what this is. Okay, so I just want to show you what each piece means. So everybody look up here. This right here is known as an integral, okay? And it is the same thing as finding the sum of all the areas of the rectangle, but this is what we're going to get into once we get past the Riemann sum. This here, the integral, means the area under the curve. So these are equivalent. This is saying find the area under the curve from 0 to pi. This is your A value, this is your B value. And what I'm telling you, what these are, is important because I think when I was talking to Kiana, I said you have to find the width of each rectangle. Okay? You need that B and you need that A. It was when I was misunderstanding what you were asking me. Okay. So, this is important because you may actually see this somewhere in your homework, and if you don't know what that really stretched out S means, then you're going to get confused. You also need to know A and B. Here, equal subintervals, what this is indicating is that delta x, which represents your width, is the same. That means if you have 4 rectangles or you have 44 rectangles, they will all have the same width. So to find the area of the rectangle, it's the width times the height. So if you have the width times the first height, plus the width times the second height, plus the width times, all those widths are the same, couldn't you factor out that width, that delta x? So we're going to put it on the outside because it's the same. We're going to do something different when it's different, but we'll get to that in a few minutes. So how do you find delta x? Delta x, which represents our width, is equal to b minus a over n. This is very important. It's not anywhere in the notes until you write it. So it's right here. Okay. This b minus a is your beginning and your end, meaning the interval over which we want you to find the area. This is the same thing here. This goes from A to B. Everybody with me? This right here is your function. Okay? N represents the number of subintervals. Really, what that means is how many rectangles are we using? And here they give you N. Okay, everybody good so far? So these are things that you need to look for. So here they tell you, all right, your widths are all going to be the same. Great, I'm going to find delta x. So delta x in this case is b minus a, which is pi minus 0 over 4. So that means this is pi over 4. That means I'm going to start at 0, then I go to pi over 4. Then I go from pi over 4 to pi over 2. How did I get that? I added pi over 4. Just like before, remember when I used 1? With the width of 1, we went from 1 to 2, and then 2 to 3, and then 3 to 4. Everybody good? Okay. So now what we want to do is we want to approximate the area using left, right, midpoint, and trapezoidal. This is the easiest one. But you have to do A and B to get D. Okay? All right. So what I want to show you first, because we're going to be asking about over and under approximation, and we don't have a graph in front of us, I want to show you on your calculator how to find the true area under the curve. If you do not have an 84, the process is a little bit longer. Okay, so if you're doing any kind of math outside of high school, it is going to be in your best interest to get something better than an 83. I'm just letting you know that. It's a little bit different process, and I can show you later. But this is what we're going to do. So first of all, I need to check my mode. For those of us that are using our calculators for other things, I'm in radian mode, so I'm good to go. You want to go into alpha window, and this is where we had a lot of different functions, but we have the derivative, which was number 3. We actually want number 4. This is the finite integral, meaning you have a finite beginning and end. So it's option 4. Okay. So depending on the software that you have, it should look like this. If it doesn't, you're going to list everything out using commas. Okay. So this bottom is actually 0. That's your A value. Then you want to jump to the top, and we want to put in our ending value, which is pi. Then I'm going to scoot over here, and I want to put in the function. For whatever reason, these problems always put the function at the bottom. It's right here. Okay, so we're going to use the sine of x. When you are integrating, guys, we are actually given the derivative. We want to go backwards. We want to go to the original function. So this is why we have the sine of x dx. This is the derivative. The integral means we're going back to the original function. I know you can integrate this in your head, but then finding the area under the curve, you're not doing that yet. Okay, after the midterm. Okay, so now we have everything filled in. All you have to do is press enter. 1, 2, 3. There's your true area. So the true area under the curve, think about a sine curve. From 0 to pi, what does the sine curve look like? It looks similar to a what? A parabola, but more specifically, what kind of parabola? Come on, folks, you're in calculus. Think about a sine curve. What does it do? Base, max, base. Stop. What does it look like? An upside down parabola. Yes! And if you didn't know that, look on the next page because it's there. Okay, so that means the area under the curve, the true area under the curve from 0 to pi is 2 units, whatever the units are. So what we're going to do in parentheses right here, just so that we have it, the true area is equal to 2. If you don't remember how to do this, you need to make sure you practice and know where things are in the menu, because you're going to be asked for it. Okay, so as I've spoken, blah, 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 we're about to do the math. There are many different ways that you guys can do this. If you have a friend that's in BC and they show you Mrs. Kim's videos, she does it a little bit different. The process is exactly the same. Me personally, I like to do the math up front, so then all I have to do is plug in my stuff. Okay? So that's what I'm going to show you. We're actually going to create a table. And remember, Ben and I were talking about how many values you're going to have. So if we have 4 subintervals, the number of values I'm going to have in my table that I create is actually going to be 1 more than n. So we're going to have 5 values. That's so we can calculate the left and then the right. Okay? So let's create our table here. Okay? We're going to put x here and then f of x here. I am expecting a very specific notation and I will explain why as I go through it. This is really important, especially for those of you that are planning on sitting for the AP exam. Okay? All right, so we know our x values will start at 0, and each width is worth pi over 4. So to get to the next x value, I add pi over 4. So this is pi over 4. What's the next value? Pi over 2. Next value? 3 pi over 4. Next value? It's pi. Isn't that where I'm supposed to end? So remember, we have n is equal to 4 subintervals. How many values do we have? 5. Remember, I told you you're always going to have one more than the number of subintervals. Okay, so now what we're actually going to calculate, which is why I created my cells so big here, is f of 0, f of pi over 4, f of pi over 2, f of 3 pi over 4, and f of pi. That means we're going to plug those values into the function. What's our function again? Sine of x. Okay. What's the sine of 0? 0. What's the sine of pi over 4? That's right. What's f of pi over 2? 3 pi over 4? Yeah. And then pi. Okay. Does everyone see where everything came from? This is going to help us with our left and our right. What we do need is our midpoint. So for those of us that forget, to get a midpoint, you're going to add these two together and cut it in half. So I'm just going to put my midpoint up here. What is it? Pi over 8? Yep, you got to cut it in half. What's this one? This is 2 pi over 4 plus pi over 4 is 3 pi over 4 times 1/2 is 3 pi over 8. What's this one? You should be able to see the pattern already. What do you think this is? Nice. 5 pi over 8. What's the last one? 7 pi over 8. I need to make sure I have 4 midpoints. 1, 2, 3, 4. Now, here's my question. We got all these values from the unit circle. Did you guys learn pi over 8s on the unit circle? So what are we going to have to use? Yeah. Okay, and I'm going to show you how to do that. So now I'm ready. I did all my setup. We have everything that we need. You guys ready? Okay. We're going to start with A, and we're going to calculate L sub 4. This is approximately, meaning I am going to approximate the area under the curve using 4 rectangles and the left endpoint. Now, when you use the left endpoint, you're starting on the left and you are only using 4 points. 1, 2, 3, 4. This is the far right endpoint. I do not use this. Does everyone understand? Okay? So, our width is the same for every single rectangle. So we are going to put in delta x, which is pi over 4, times. This represents the width of every single rectangle that is going inside the parentheses. To find the area of the rectangle, it is the width times the height. What represents the height? F of whatever, right? Okay, so this is f of 0 plus f of pi over 4 plus f of pi over 2 plus f of 3 pi over 4. This notation right here is extremely important because if I make a, you know how I make typos in the calculator? If I make a write-o, like meaning I write something, prime example, if somebody knew they had to write something on the test, it was pi over 4, would they write pi over 3? I asked them why. They don't know. You're in test mode. You're not thinking sometimes and you just write something. It happens. If you put this setup on the AP or the final exam or even on the test, but you make a calculation error, you will not lose all the points. Do you see what I'm saying? This is the setup. Now, when I plug in the actual values, if I make a calculation error, at least I have a couple points. I'd rather have a couple points than none. Agree? Okay, so here we go. We've got pi over 4 times f of 0 is 0 plus square root of 2 over 2 plus 1 plus square root of 2 over 2. Where did I get all those values from? Oh, the table. Okay, that's easy because I already had it, right? Okay, this is pi over 4 times, that's gone. Square root of 2 plus square root of 2 over 2 plus the square root of 2 over 2 is square root of 2 plus 1. 1 plus the square root of 2. If this was non-calculator, I would have to stop, right? I can't do anything else. I don't know these values. I mean, I think I'm smart, but I'm not that smart. Okay, Use your calculator. Give me an approximate value of the area to 3 decimal places, please. Mm-hmm. 1.896 or 8961, right? Okay. So if we do 4 decimal places, this is what this would be if we truncated. So here's my question. If you were given a problem like this and you were not given the graph and I said to you, you have the function, you have everything, is this an over or under approximation? What are you going to say?
Under.
Because you found the true area, right?
Yeah.
So you would say under approximation. In this case, I can't ask you to justify your answer because really it would just be, well, I know the true areas too. You don't have the graph. Make sense? Okay. Everybody okay with the first calculation? All right, now when we're doing R sub 4, this is part B. R sub 4 is equal to, we have delta x, it's pi over 4. Now you're going to start on the right and take the 4 endpoints from the right. So you've got this one, this one, this one, and this one. Don't use this one. You only want 4. So you've got f of pi plus f of 3 pi over 4 plus f of pi over 2 plus f of pi over 4. Okay, do me a favor and find the area, please. Yes. Does that scare you? Sorry. So what did you say? Can you say it out loud? It's the same. Can someone tell me why this area would be the same? Think about the graph. Yes?
The only difference is which endpoint you use and they're both equal to 0.
True, but also too, think about the graph. So we said that that first part of the graph looks like an upside down parabola. Tell me about parabolas. What is a unique graphing characteristic of symmetric? Okay, so that means this area, 1.8961, we know it's an under approximation. Okay, is that always going, I'm just going to abbreviate. Please do not abbreviate when you are answering your questions, okay? Is this always going to happen? No, but it's the function that we have right now. So that's something that we need to think about, okay? So let's talk about midpoint. All right, so in C, we've got m sub 4 is equal to. Is our width the same? Yeah, width is the same. We just need the midpoint of the rectangle. So we've got pi over 4, and we were smart because we calculated those midpoint x values in the beginning. So we've got f of pi over 8 plus f of 3 pi over 8 plus f of 5 pi over 8 plus f of 7 pi over 8. Now, we already discussed that we don't know what these values are from the unit circle, so we get to use calculator. Okay, so what I need is everybody's attention up here. We're going to go into y equals and clear out anything that we have here. We already checked to see that we were in radian mode. And we're going to put our function in here. So our function is the sine of x. Sine of x. I'm going to go into the home screen and start fresh. So I am going to type in exactly what I see, except in my calculator I can't write f of. I need to state where the function is. Where is the function? Y sub 1. Okay, so watch carefully. I'm going to put in pi over 4. I don't want to forget that width. And then I'm going to open my parentheses. And I'm going to go in and grab y sub 1, which is the notation for f of. So it's alpha trace, there's all my y's. So if your function's in y sub 2 or y sub 0 or wherever you put it, then you need to grab that one. I've got y sub 1. Now this is annoying because you got to type it all in. We don't have a copy paste. We don't have a mouse that hooks into our calculator. Sorry. Okay. So you open your parentheses and you want to tell the calculator where you're going to evaluate. The first one is at pi over 8. So you're going to put in pi over 8 and close your parentheses plus. Now we need to do 3, 5, and 7 pi over 8. So you need to do the same thing. Bailey, you okay?
Yeah.
All right. And you need to sort of take your time a little bit because I always make a typo here. Although you guys are probably better than I am at this. Parentheses. 8 plus. Okay. Everybody got it all in there? So as you are typing, let's make sure that I put it all in right. I know what the answer is. Yes, I'm good. So you can look up here and check your answer. .0523, and this is an over. Is everybody good with the typing? It's annoying because it's time consuming, but at least you don't have to do all the math in your head. Right? Okay. Questions on how we get this answer? You guys good? Okay, you got to make sure the most common mistake, someone will come up to me, they're like, it doesn't work. Function's not in y sub 1. It's either not in there at all or it's in a different y. Okay, so just be careful. All right, the last one, trapezoidal. The easiest one, but you have to have calculated L and R. So, I did not give this to you yet, but to find the trapezoidal, which in this case is 4, we're going to take our left plus our right and divide it by 2. Okay? Well, in this case, because our left and our right are the same, and we're dividing it by 2, what is the approximation for trapezoidal? Yeah, it's 1.8961. Yeah. And again, remember, it doesn't always happen. It depends on the function.